Hi, how are you guys? Students, we're gonna talk today about the Pythagorean theorem in this new week. I hope you're feeling great. And here, here we have the work of this week. We're gonna start as set with the Pythagorean theorem, and let's make a review of what we actually saw last year doing geometry. Here we have a right triangle. How do we know this is a right triangle, Mick? How do we know this is a right triangle? Come on, Mick. You have to refresh your memory. So this is a right triangle. How do we know it's a triangle? Mick, how many sides do we have in here, right? 1, 2, 3. Yes, we have 3 sides, and this is a right triangle because it has a right angle over here. Do you see, Mick? Oh, yes. Okay, so this is a right triangle, and it has a right angle, which is an angle of 90 degrees, right? And how do we call this side, and this side on a right triangle, Mick? Come on, let's remember. So let's see the sides that are touching the right angle, right? This side is touching the right angle, and this we're gonna call them legs. So this is gonna be a leg, and this is gonna be a leg. Okay, and the side actually that is opposite of this right angle, we're gonna call it hypotenuse. And as you can see, the hypotenuse, it's the longest side. It's in front of the right angle, and actually it touches both legs, right? So it connects the 2 legs, the ends of the 2 legs. So we're gonna call this the hypotenuse. Okay, and then let's suppose the one of the leg, maybe we should use this color. We're gonna call this leg A. This other leg here, we're gonna call it B, and this leg here, we're gonna call it C. Oh, sorry, this the hypotenuse, we're gonna call it C. So we're gonna have, and that's the Pythagorean theorem. We have A squared plus B squared equals C squared. You remember that, guys? So the Pythagorean theorem, it's very useful when we're trying to find one of the sides given the other 2. So if they give us the hypotenuse or leg, we can find the other leg, or if they give us the 2 legs, we can have the hypotenuse. So let's look at the exercise that we have for today, and the exercise that we have for today is this one. Let's start with the first one, which is number 1. And here, the first thing, we have to identify the legs and the hypotenuse. So let's go, Mick. It's your turn. Can you tell me, please, Mick, which one is the or first, where do we have the right angle? Here. Yes, here. So, and then what is this, Mick? What's this in here? Leg. Yeah, this is one leg. What about the other one? It's in here, right? Yes. The hypotenuse. Where's the hypotenuse? It's X. So here again, let's write how the formula is. It's A squared plus B squared equals C squared. A squared plus B squared equals C squared, where A is one leg, B is another leg, and C is the hypotenuse. So what are we gonna write? What are we gonna write for A, Mick? 6. Okay, we can write 6 or we can write 8. It doesn't matter. It's exchangeable. So we're gonna have 6 squared plus 8 squared. That's gonna be equal to x squared, right? And 6 squared is 36. 6 times 6. 8 squared is 8 times x, which 8 times 8, which is 64, equals x squared. 36 plus 64 is 100. So that's 100. X squared equals 100. When we take the square root, remember it's x square root of 100 plus minus when we solve an equation, and that's going to be square root of 100 is 10, because 10 times 10 is 100, so plus minus 10. Because we're talking about geometry, a negative answer wouldn't make sense, So it's gonna be just 10, right? So x is 10. That's an easy one. So guys, remember first identify which one is the hypotenuse. So you can do that one. When the hypotenuse, instead of trying to find the hypotenuse, we're trying to find a leg. This might be for some students a little bit more difficult. Okay, write it again now, and be careful with this. How much is the hypotenuse in here, Mick? 9. No, Mick, it's not 9. Look, this is the longest one, and it's in front of the right angle, so it's actually 16. 16 is gonna go here and see 16 square, and then equals. So then this can be x, right? And then plus 9 square. So now we're gonna have 9 square, which is actually 81 plus x square equals, and 16 square, I think, how much is 16 square? Let's do it with a calculator. So with a calculator, we're gonna do 16 to square, which is this button here. Do you guys see? Yes, right, square, which is 256. So here we have 256. And now when we try to solve for x, we have to actually here subtract. The operation we're going to do here is subtract both sides. Minus 81. So that's the same thing as this 81 going here as subtracting. So x squared equals 256 minus 81, and that's how much? Minus 81, which is 175. 175. So x squared equals 175. Now we have to do the square root both sides, so we have x equals the square root of 175. Now the square root of 175, if we do it here, clear. Here we have the the square root, second square root of 175. This is not a exact number. It's 13.22, right? But instead of putting 13.22, which would be okay, we can also try to put it in a way that it's more beautiful. We can do the factoring, trying to find the factors inside of 175. So 175, if we divide over 5, 175 over 5, 175 over 5, that's actually 35. So we can put here 5, which is actually a prime number, okay, and then 35, and then inside of 35 we have a 5 again and 7, right? So that means that 175 is 5 squared times 7. So we can write this as x equals square root of 5 squared times 7. This 5, as it has a square, can go out of the root. And what we're going to have is 5 times the square root of 7. Okay? So we can write it this way, which is very beautiful and it's exact. Okay? I'm sorry that I have gone too far down and I have kind of filled this problem number 5. Which I also want to do number 5. To do number 5, we're trying to prove if this is a right triangle or not, and if it is a right triangle, that means that the square of this plus the square of this must be equal to the square of this, right? So that means that 11 squared plus 3 square root of 15 squared equals 16 squared. And now be careful with this. We have to make sure we know that a times b squared is a squared times b squared. Okay, so we are squaring the 3 and the square root of 15. Okay, let's keep going then. 11 squared is 121. Then again we're squaring the 3 squared, and then we're squaring the square root of 15 squared. this equals to 56. As we saw before, that is that the square of 16 is 256. Now, square root of 3 is 9, right? Square root of 3 is 9, so we have 121 plus 9 times, and then the square root of 15 square. This is the opposite operation, so this is going to cancel with this. You can do it with a calculator to see that you get 16. So times, so 15. 15 equals to 56, okay? Now, 9 times 15, let's go do this with a calculator, right? So 121 plus 9 times 15, this is 256. So that means that actually this side is the same as this. So that means that this is the right triangle. Okay, so this is, yes, this is the right triangle. That's it. We proved that this is the right triangle. Okay, now the last one is a review of similarity. We did this last year, similar triangles, and if you can remember this from last year when we have actually this kind of problem. It can be proved that this triangle is actually similar to this one. You can also you can actually see it right away that this angle here, it's the same as this one here, while and it's the same because if you would move this one down, this is actually this, and this is the same angle, or you can move this up, it's actually the same one. Okay. And this will be, this angle here will be the same as this. Okay, it can be proved. I'm not gonna go that far. It is if you have trouble with this, you can ask me to prove that these are similar triangles. Now, again, when we think about similar triangles, we have to think that they actually, if this side is the corresponding of this one, or even easier than that, the hypotenuse. This would be the big hypotenuse, right, of the big triangle. Well, this would be the small hypotenuse of the small triangle. What you have to think when we think about a similar triangle is that actually this side compared to this side has grown as much, or has gotten smaller as much as this one compared to this, or this one compared to this. What is it wrong? Yeah, that's right. So again, you have to think which one is the big and the small of each one. Okay, so there now. Also, this is also a similar triangle, okay? So, and this would be the really big hypotenuse. So we have the hypotenuse of this, the hypotenuse of this, and the really big hypotenuse, which would be this one here, of this, the whole triangle. So, and now, let's see, they're asking us x, so it's the hypotenuse of the really small one. So we know that the really big h, which is this one, over this small h, which we're gonna call it x here, okay? The way that the hypotenuse has grown is the same as any other side. So, and now we have this one here, compared to, let me see. So we have, So, okay, so we can know, okay, so if you subtract 25 minus 9, that's 16, and this is this one here. This is this side here, right? 16. So we have this, this, and this. Okay, so now this, trying to find out. So this goes with this, and then let me think for a second. So to try to understand better this problem, what I have done, I'm trying to graph all to draw all the triangles in a nice position to compare the sides. So this one is the first one, the small one, which I graph here, this side 9, and then the hypotenuse here, and then this is this side, right? And then now the middle one, which is this one here, okay? And the middle one would be, now we have this here, then we know that this is 16, right, which is this side, and then this would be the middle hypotenuse, right? We're gonna write it like this. And then let's write now the really big one, which is this one, the really big one, which is this one here, which will be x, which is this side here. Then this will be the base, okay, which is the, actually this base here, the really big base, which is actually the middle hypotenuse of this one, okay, of the middle one. Let's write an m here so we don't do mistakes, okay. And now this would be the really big hypotenuse, okay, the really big hypotenuse. And then this is this, and then this is also the small h, right, the small hypotenuse in here. Okay, so now this hypotenuse is actually 25, as we see in here. The big hypotenuse is 25, this is 16, and then this is 9. But also, let's see, this is x. Okay, so here we go. So now we are trying to find, this is this. Now let me think a little bit more. So after looking at this and thinking a little bit more, it looks like this over this, right? On a similar triangles, if we divide this over this, that's going to be the same as this over this, or this over this. So when we divide two sides that are actually the same ones, we're going to have the same ratio. Okay, so if I do x over 9, that has to be the same as 25 over x. 25 over x. If we solve this equation, okay, we can cross multiply. So we're gonna have this x times x, which is gonna be x squared, and 9 times 25, which is 9 times 25, 9 times 25, which is 225. So we have x squared equals 225, and when we take the square root of 225, isn't it this 15? Yes, it is 15. So that means that x is 15, and it looks like it makes sense. So x equals 15. So again, it's not a difficult problem, but you need to write down things before you can solve it. I'm not sure if there's any other way to solve it than this. I don't actually. The base of the big one isn't it 16? 16 here. Isn't this 16? It is, right? 16. No. This is no. It's this one. I'm sorry. Now, I was trying to check if there is another way to solve it, because we don't have x in here. No. So this is the only way to solve it. So yeah, that's it. I hope it helps. Bye.